last word in nuclear fission designs. And the last, of course, concept was different from the earlier design. It's a very small, compact design, extremely high yield in a very small size, so you could say the efficiency is tremendous. And we were all very proud of it, and when the 4 tests were successful, we were happy, and this is this was the last thing we did. And this was in the earlier part of the 90s. So now I think that the rest is all history, and it's very recent history, so it's all in the memory of the people. That now we had all these designs available with us. I will not tell you what we've been doing beyond that. And then you also have to weaponize them so that they become deliverable weapons. I will not tell you what we did with that, but you can draw your own conclusions. And of course, we have spent our lifetimes on this program, and still no chance of a hot test. And on the morning of the 11th of May this year, one of our friends in the armed services, he phoned me and he said, have you heard the news today? I said, what? He said the Indians have conducted the explosion in Pokhran. So I said, congratulations. I was genuinely happy. I was very, very happy. He said, you are congratulating me on the Indian test? I said, yes, because now we will get a chance to do our own tests. It's always happening like this, that the Indians do something first and then we follow suit. Although as scientists we would have liked that the government would have allowed us to do the tests in our own normal way, so we develop our scientific process properly and in time. But anyway, these are political decisions. And when the Indians conducted the test, within 2 days they conducted another test. They claimed that they conducted 5 tests in all, 3 on the 1st, on the 11th, and 2 on the 13th May. Several people have queried on this. They have thought about it. What were these tests? Of course, the claims were that they conducted 5 successful nuclear tests. We have our capability of detecting nuclear tests, measuring their yields and so on. And the 3 tests on the first day, they claimed that one is a fission device, and one is a fusion device, a hydrogen bomb in other words, and one they said was a low yield device. We have detected only one explosion on that day. And the yield of that explosion, according to all our measurements, and you know we are across the border and our measurements are the most reliable and the data is the most accurate. And the yield was same as of the 1974 Pokhran test. So I think the first test, we all thought that the first test they did was a repeat of the 1974 test, and the yield was the same. We did not detect a thermonuclear test. We did not detect any smaller test because we can detect smaller sub-kiloton tests which are of the order of half a kiloton or 1 kiloton, but we could not detect that. So our estimates were that they only conducted 1 test. Later on, when the international data started coming in from all over the world, it was also said that on the 11th of May, they only detected 1 test. Of course, the yield measured at far-off stations had a greater error on it. They gave a very wide range of yield. They said it could be between 10 kilotons and 25 kilotons, or 10 kilotons and 40 kilotons, but this because the further the stations, the more the error margin of error. And on the 13th May, they said they did 2 small tests, but we did not detect any test at all on the 13th May. And our capability, as I said, is between half a kiloton to 1 kiloton. We should detect that. So after these Indian tests, then as we expected, very quickly, the Prime Minister was at it. He called me and he said, are you ready for this? I said yes, and he said okay, then just get yourself ready. And I told my colleagues here that we have to be ready, and so all they had to do was start packing. But we didn't go to Charlie, but we started packing. And then we went on the 20th May, and we conducted the first test on the 5 tests on the 28th. And one test was a huge explosion, a large device. The other were sub-kiloton tests. And on the 30th, we went into the L-shaped shaft in the Haran Desert, and we did the test of the last of our models, the latest of our models. And in all, we conducted these 6 tests. And the results are that all the tests were successful to the hilt, to the last detail. The yield always was as predicted by our theoretical physicists. So this is because which gave us the maximum pride, because I can assure you, they can design a different device. You give them a specs, we want this yield in this size, we want this much yield and this much size, and they will be out with their design in 2 months, and Dr. Baig will be out with the actual bomb in about a year or so. So this capability is now with us, and this is a great capability, and it's a tribute to thousands of our scientists and engineers and geologists and metallurgists and theoretical physicists who have really spent more than 2 decades on this program. And it's also a tribute to the vital link in the chain at KRL, who are successfully doing the enrichment of uranium. Very smoothly, the process is going on for so much time now. And we have got so much data from these 6 tests that it gives us so much confidence in our design capability that, as I said before, that we can design any specification, any weapon we want. Maybe we acquired this capability from somewhere. Somebody came and gave us some drawings. Somebody came and gave us some knowledge or transfer of technology. I can swear to you that nobody in the world, no matter how friendly he is to Pakistan, how friendly that country is to Pakistan, I can tell you on oath, nobody has ever helped Pakistan by giving us any transfer of technology. It's purely Pakistani effort. It's an indigenous effort, and this should be really hammered in, that because this is going to give you the pride. This is the pride of the nation, that you have done it. Pakistan has done it. Nobody has given us. This is not borrowed technology. We have not purchased. We are a generation of scientists who have lived under embargoes right from the mid-70s. The day India exploded the bombs, the embargo was on Pakistan. And we are a generation, I sometimes tell to my colleagues, we are an embargoed generation. We have learned to live under embargoes. Nobody will give us literature, nobody will give us technology, nobody will give us hardware, nobody will give us components. For everything we have to struggle. So we have worked under these adverse circumstances, and in spite of all these adverse circumstances, my colleagues, they took it as a challenge that, okay, you make life difficult for us, we will show you how to do it. And this nation of Pakistanis, it works best in a handicapped mode. When you are facing a challenge, you show your best. And I firmly believe this, that the young people in this nation, they are capable of reaching the skies. And the last thing I want to say is that the Atomic Energy Commission has proved in this country that it is an island of excellence. And to substantiate my statement, let me say this, that if you take the world, the statistics from Pakistan and compare it with the rest of the world, the life expectancy at birth is, Pakistan is 122nd in the world. The children, as soon as they're born, they die. And what is the life expectancy? So we are 122nd in the world. In literacy rate, we are 162nd. We are at 162. At per capita income, we are 120th in the world. Out of all the countries in the world, we are 120th. Now, in health services, the access to health services, 148. Access to clean drinking water, we are 114th nation in the world. Then the overall human development index, which is the overall gross index for human development, how developed you are, we are 139th country in the world, almost the last. And of course, in nuclear weapon states, we are the 7th in the world. And this is because the Atomic Energy Commission worked in this country in difficult environments with certain traditions of excellence. What are those traditions? Number one is, there is a tremendous team spirit. Nobody works in our organization for money or for fame. You haven't heard about us before. We don't believe that sensitive work can be done by publicizing it. It should be done quietly, and so there is no lust for fame in this organization. There is honesty, there is dedication. The work is dangerous. You are working with explosives, you are working with atomic bombs, you are rubbing your shoulders with nuclear weapons. Who can pay you to do this? Who can pay people to work in explosive plants and do explosive machining? No, everybody loves life. Only the people who are dedicated, who have really put it into their head that, okay, we are going to make Pakistan into a nuclear power, they will do it. People with a purpose, with a motivation, with a target in life, with a high philosophy in life would do this work. So, team spirit is the third thing I want to emphasize. A large number of people work together for a long period of time, intelligently, they achieve a big objective. If one person works hard for a long period of time, as an individual, he will only achieve a small objective. In our organization, there are about 15 to 20 directorates, each dedicated to a part of the nuclear weapons program. Each directorate has about 700 to 800 people, and they have worked for more than 25 years, consistently and quietly, and without publicity, and without greed, and without quarreling with each other. And I tell you this, that the miracle of teamwork I saw in Charlie. When we were there for about 10 days in all. And the Prime Minister told me when I was going there, he said, Dr. Sahab, please don't fail. We cannot afford to fail. If we fail, we cannot survive. This is an hour of crisis for Pakistan. He mentioned what the Indians were saying, and he was dead sure that if the detonations fail, they are going to attack our nuclear facilities immediately. And he said that we can't afford to fail. So there was a sense of responsibility, a tremendous burden of responsibility when he said this to me. And I came back to my team and I said, this is a responsibility, let's all share it. We are a team. And nobody let me down. And everybody in the team, we worked together, we worked as a team, And there were difficult moments during those 10 days. There were technical difficulties during those 10 days. We took collective decisions and we solved those problems, and we were there on target on the 8th day on the first 5 tests. And this is not a miracle. This is not a miracle. This is something you achieve after you worked a lifetime. So, team spirit was very, very much there, and with so much of responsibility on the shoulders of so few, one would expect them to be tense, expect people to be quarreling with each other, to be abusive, to be bad-tempered, but you would have been surprised if you had visited Charlie in those days. People were all smiling, they were all in good spirits, they were all very cheered up and very, very relaxed, because we all believed that we have worked very hard and God will give us success. And success He gave us. Thank you.
A high philosophy in life. This, I think, is the crystallization of Dr. Samar's speech. These were the mileposts of an odyssey, a nuclear odyssey, so succinctly and concisely retraced and delineated by Dr. Samar. We thank you a lot, sir. A number of lessons that I have learned from Dr. Samar's speech is, number one, there are no shortcuts in science. You have to go all from the scratch work, all from paperwork, and then build whatever you aim at. And number two, I'm also impressed by the interdisciplinary character of their work. People from all scientific disciplines, including metallurgy, basic sciences, theoretical chemistry and physics, civil, mechanical and chemical engineering, and even health and radiation diagnostics, were all a part and parcel of the nuclear program. They owe a lot of ovation. Now I would like to request the Vice-Chancellor of the Punjab University and the guest of honor to confer shields and souvenirs to the guests. First of all, I would like him to proceed forward, Dr. Khwarizmi. Dr. Samar Mubarakmand, a doctor of philosophy in experimental nuclear physics, led the team that was to detonate Pakistan's first nuclear device. He is member technical of the Pakistan Atomic Energy Commission. His special career expertise is in the fields of nuclear instrumentation, fiber optics, lasers, nuclear weapon systems, nuclear diagnostics, and missiles. In reward of his outstanding achievements, he was bequeathed with the Hilal-e-Imtiaz from the government of Pakistan. Please, sir. Next on the panel, we have Dr. Khalil Qurehi, a wonderful metallurgist in his own right. Dr. Khalil Qurehi is presently the Chief Scientific Officer in the Pakistan Atomic Energy Commission. He is the Senior Director in the Directorate General of Technical Development. He is associated with the Uranium Metals Laboratory, converting volatile uranium hexafluoride into hardcore uranium metal. His special areas of specialization are metallurgy, reactor fuels, uranium and plutonium, and materials science. He is also an author of reputed books and monographs. He was also a recipient of both the Sitara-e-Imtiaz and the Hilal-e-Imtiaz from the government of Pakistan. Dr. Khalil. Next on the panel, we have Dr. Masoor Ahmed. Dr. Masoor Ahmed is the Director of Theoretical Physics in the Pakistan Atomic Energy Commission. He heads a very important group in the design and development of nuclear devices. He has developed the simulation and computer codes which play a very decisive role in the developmental program of Pakistan's nuclear odyssey. At the nuclear devices tested on the 28th May and the 30th of May, he had designed all the computer codes and all the experimental results matched exactly with the theoretical predictions. He was also conferred upon with the award of Pride of Performance and the Hilal-e-Imtiaz by the Pakistani government. Dr. Masoor. Last on the panel, we have Dr. Mirza Mansoor Baig. Mirza Mansoor Baig is the Chief Scientist and the Director in the Directorate of Technical Development, Pakistan Atomic Energy Commission. A producer of the Government College, Lahore, he heads the diagnostics of the detonation and the geologic design of the tunnel, as Dr. Samar has just delineated. He is basically a neutron expert, diagnosing, testing, and calculating all the neutrons that are emitted as a result of a nuclear test. His significant contributions to important national projects have brought prestige and laurels to Pakistan. He was a senior member of the team of scientists involved in the successful nuclear detonations at Shawi. Dr. Mirza Mansoor. I would now request Dr. Khalil Qurehi to present a momentum of remembrance to the President of the Khwarizmi Science Society, Dr. Saadat Anwar Siddiqui. Praiseworthy are also the efforts of the Interactor and the President of the Interact Club of Lahore Sharqi, Tahir Habib Chima. He will also be bestowed with a memento. In the end, I would request the President of the Khwarizmi Science Society, Professor Dr. Saadat, to confer upon the Vice-Chancellor of the Punjab University, Professor Dr. Khalid Hamid Sheikh, and the guest of honor of today's proceedings for prizing our Now we shall have a panel discussion. All the participants and the audience are invited to put across their questions. Your questions should be addressed to me and I shall mediate those questions. They should be brief, precise and concise, to the point, and the questions should be preceded by your full name and organization or institution. If someone is not confident that his voice would be in the earshot of everyone, he may come over to this solitary microphone and put across his question.
My name is Ijaz Rani from Manufacturing and Quality. I would like to ask the Honorable Guest, Dr. Khwarizmi, about when he says that the cold tests were fail-safe practically. They were more than 100% assured of success. What eventually necessitated the actual detonation? Why was the detonation made? And in the aftermath of what's happening economically, the squeeze which has transpired since then, what are his opinions now?
You can use the microphone. It is detachable.
Thank you for your question. The cold tests, they confirm that your design is okay. But what is the efficiency of the design? What is the yield of the design? For that, you have to conduct an actual hot test. A cold test confirms that if you detonate this bomb with an enriched uranium core, then it's going to work. But how well is it going to work? For that, you have to conduct an actual hot test. All the big nuclear nations in the world who are nuclear powers, the P5 nations, each of them has conducted several hundred hot tests. And therefore, a hot test has to be conducted, and a cold test is not a replacement for a hot test. It does give you a lot of confidence. Now, as far as the question about landing Pakistan into economic trouble is concerned, let me say this, that we are very clear in our mind. We have not conducted the hot tests just for the fun of it. The neighbors, the Indians, conducted the hot tests first. Then there was a tone of aggression from across the border. One thing they said was, there is no problem of Kashmir. You just vacate Azad Kashmir and the problem is solved. Then another thing they said was that you are sending, you are aiding the Mujahideen in Kashmir, and we will come across the border and destroy the training camps in Pakistan. Then also we are very well aware of the designs to attack our nuclear installations in connivance with some other powers, and they had these aeroplanes ready to do that, and they were planning to do that on the morning of the 28th. Now, with all this happening across the border, and also one of the statements I remember, the Prime Minister said, we have brought the Defense Minister said, we have brought now Pakistan on its knees. Now you're talking about economic problems. You know that in the context of South Asia, if you have one country which is so aggressive and which is so dominant, and you don't do anything about it, it's going to dictate all the economic policies, the trade policies, the import-export policies of the region. It can also control your internal situation by creating unrest in your industrial cities. It can disturb your industrial peace and grind your industrial activity to a halt. So these are all these steps can affect your economic activity ultimately. We did not detonate the devices till the 28th. Do you remember what was the stock exchange doing in those 15 days? On the 11th May, the stock index was 1550. And on the 28th May, or on the 26th or 27th May, it was close to 1000, just under 1100. Why was this happening? Because of the perception of the people that if we are not strong enough, we are going to buckle down in any case. And then, if you would have had a nation which would have been economically damaged. Suppose they went into Azad Kashmir and created some trouble there. The refugees from Kashmir would have come into your big cities. We would have had an immense refugee problem. So there, in that scenario, one could have had an economically crippled nation which would have been demoralized as well. Now we have a nation in economic difficulty. I'm not saying it's crippled. It's a nation in economic difficulty, but at least it's not demoralized. It can fight back. It can fight back its problem.
Any more questions? Mr. Bakarski, please.
My name is Samar Mubarakmand. I am from the University of Engineering and Technology. I have two questions to put to you. Firstly, how do you compare our nuclear capabilities and India's technically? And secondly, we are nowadays hearing a lot about PDB, etc. Suppose we sign those, and what hindrance will they cause to our research and
Okay. You only compare capabilities when you know exactly what the capabilities are. to draw a comparison, we must know the details of the Indian capabilities. We can only guess their capabilities from what they have done outwardly. We are aware of the fact that they have conducted a fission device test with a yield of about 12 kilotons. And this they also did in 1974. Now, beyond this, there was a statement of the Indian Defense Minister who said that we will now go for weaponization. Normally, after you conducted a successful nuclear device experiment, then weaponization takes about 6 to 8 years. If what they have said is true, then Pakistan is well ahead of it. But on the other hand, I would caution the country, and I would caution all my friends here, that we should not underestimate the enemy.
Please, Dr. Afaq.
I'm Dr. Khalil Qurehi from the Institute of Nuclear Medicine and College, and I would like to point out two things, sir. One, that since the topic was an odyssey of emergence of Pakistan nuclear power, the fallout of atomic device detonation in the press and in the various books and pamphlets written afterwards, it has got a tremendous effect on the people. Is there I don't know if there is any homework inside PAEC, but is there any plan to, contradict those things and put the straight facts in a book form for the people and for the world? And my second question is that you have mentioned that you have got a team effort and so many incredible things. That is Pakistan Atomic Energy Commission doing anything to sort of compile all these things and put forward for the government and our educational institutes to follow those guidelines?
Thank you. Well, as far as your first half of the question is concerned, it's not really a question, it was more of a comment. We have gone through a mixed kind of an experience after these tests. When we came back from Chagi, when we were there in Chagi, we were completely cut off from the rest of the world. And the telephone facilities and the television, we had television, we didn't have time to see it, but the communication with the rest of the world was more or less not there. So when we came in the C-130 aircraft and we landed at Chaklala on the morning of the 31st May, it was a surprise because just 5 minutes before landing, the pilot said to me, "Doctor, please mentally prepare yourself for prepare yourself." I said, "Are you going to crash?" The C-130s are notorious for this. I said no. He said no. A huge reception is waiting for your team. So this was news to us. We had no hand in this reception. When we landed at Chaklala base, thousands and thousands of people were there to receive us. All the world media was there to receive us. This was a big shocker for people like us who tend to keep our work hidden. We tend to keep our names hidden. We just want to work in peace and in quiet. And that, I suppose and I believe, is the only way to do nuclear weapons work. This is the only way to do it. So for us it was a shocker because we had never been exposed to media and to glaring camera lights and so on. Anyway, we are grateful to the people of Pakistan who honored us on that day. And subsequently, some controversy erupted in the press and some books have been written on this thing. And I don't want to get entangled into that because that creates a bad feeling. All I want to say is that from our side, from the Atomic Energy Commission, we are not fond of publicity. We would not like to go around trumpeting what we have done. What statement I gave today, the speech I gave today, is a statement of fact. there is not an iota of mistruth, of falsehood in it. And so from this, whatever you heard today, I think that everything is very clear to everybody. We have all played our due role in the nuclear program. The Kokhra laboratories, the Atomic Energy Commission, the Pakistan Army, they helped us a lot during the tests. So everybody, chipped in because this was a national effort. And it's the culmination of the successful culmination of the nuclear tests is a tribute to the entire nation and to all the technical engineers, scientists of the nation. It's a collective effort, and this is the way we see it. And as far as the second thing is concerned about writing a book, I suppose that in the Atomic Energy Commission, we are compiling the history of the nuclear program. Somebody is doing it at the moment, and as soon as it's written down, we will like people to read it, because now there's nothing secret about atomic weapons. We have already explored them, so there's some degree of openness about it. The degree of secrecy should now be on what is your inventory, how many weapons you have, where have you put them, where have you stored them with. That is something one should, what are the designs, details, that is something one should not talk about. But everybody knows we have weapons. So there is no harm in writing about the history of how the program went about, and that is being done.
You may also target your specific questions to the other panelists. Dr. Chaudhary.
I was in Australia when the test was conducted, and some international nuclear experts they analyzed that India had enough time to prepare for the test. Pakistan only had 2 weeks, and that shows that Pakistan capability is a lot more mobile, the weapons are a lot more they analyzed that India had enough time to prepare for the test. Pakistan only had 2 weeks, and that shows that Pakistan capability is a lot more mobile, the weapons are a lot more modern. While Indians would have had huge, very weighty weapons, Pakistan had to do everything in a couple of weeks' time. So this was just what the international press said. And that shows that's a good news for us, that we had better technology. And I have a couple of questions. Perhaps, can I?
Yes, you can.
First is that Dr. Samar, that first, what are the plans for developing the neutron bomb and hydrogen bomb? And what sort of program has government got to guide the missile production? Because I guess that we have some program. And one question, Dr. Mansoor Baig. Admitted this design of atom bomb in the cookbook, which is available all over the world. In fact, some university in USA published even the students' newspaper. So why did we choose to ignore that? I mean, that is true that was the whole technology of 1945 bomb. And to be completely ignored, we developed our own technology. So I just want to know, what the reasons were. And the last question is, what is to produce a bomb of affinity at 20 kilotons TNT? How much uranium 235 do we need? Just say, if there's no secret in it, I'll be grateful. Keep that secret. I don't know.
Okay, just the first comment you made. The Indians got motivated to do their atomic tests because it was a mandate of the BJP government. And they were triggered, they were pushed into it by the firing of the Lahore missile. The Lahore was fired on the 6th of April. And they did the first test on the 11th of May. I believe, and there are certain information we have access to, which says that they immediately set about preparing for the test. Now, they took a month to prepare for their tests. What I want to say is that they worked quietly, and they prepared for the tests and at layer. They took, I would say, 4 weeks is really a layer. It's a long time. And if they had failed in the tests, they would have, as they did in 4 of their 5 tests, and if they had failed in all their tests, the world would never have known they conducted a test. So this was the Indian scenario. For us, imagine working under a spotlight. 15 satellites, they moved from their orbits and they made them pass over Charles. Every night, every 30 minutes, 20 minutes, there was a satellite moving across the skies, and we could see it because it was like a flash of light going across. At night you can see all of them. So we were working under a spotlight, and we were working under the threat that if we fail, the Indians are going to take us out. And there was a red alert also on the 27th, 28th night. Now we had to work under that spotlight. The entire world media was sitting in Dalbani, sitting on those tea shops at 50 degrees centigrade. What are you doing? We are travelers, we're just passing through, coming from Iran, going to India. They're just sitting there, BBC and CNN and everybody sitting there. And every truck would come into to Chagi with cement, and they would say, okay, they are plugging the tunnel. And something would happen, a helicopter would pass, okay, they are, so and so is going and so is coming. So working under these conditions, under a spotlight, makes you really tense. But thank God we succeeded, and we worked very in a relaxed way, and God has helped us. The mobility of the weapon systems, I tell you that we transferred all the weapon systems from here to Chagi, and they went by aeroplane, they went by chopper, they went by truck, they went over a terrain which there was no road, there was just stones and rocks and boulders, and the trucks, when they went over there, you can imagine the jolting and the pushing and the shocks on these devices. And every weapon worked successfully. This is a tribute to our people who have done the quality control over the weapons and how ruggedized they are. So they were, as you said, they were very mobile systems, they were very efficient systems, and they were transported in quick time. And we didn't get those 15 days to do it. As I said to you, that Prime Minister said, okay, now you can go. On the morning of the 19th, he said to me, and on the 20th we moved from here. And on the 28th we conducted the first test. So we did it in 7 days. On two different sites, 150 kilometers apart. And we had 70 people here and 70 people there and doing all the work. So this was the first part of it. The second part, Dr. Masoor will tell you.
Dr. Mansoor Baig.
Mansoor Baig will know the question about how much uranium in 20 kilotons Dr. Masoor can say, and the other part Dr. Baig can answer. They were very mobile systems, they were very efficient systems, and they were transported in quick time. And we didn't get those 15 days to do it. As I said to you, the Prime Minister said, okay, now you can go. On the morning of the 19th, he said to me, and
I want to elaborate on this point, that the design which you can download from internet, they are just sketches. They are just showing that these are the materials. In a nuclear weapon thing, the whole thing is quantitative. What material, how much is the quantity, what is the yield, and how much is the reliability. Now when you want to do that calculation, you need some of the fastest computers to calculate those things. For testing, we tested some of the internet designs. So it so happens some of their designs, they don't become even supercritical after detonation, which is disaster. Some of the designs are supercritical even before detonation. They are unsafe. They can kill the designer altogether. So the real thing is quantitative. The very idea that you are asking how much quantity of U-235 is used for a particular yield, say 20 kilotons. No designer will tell you the exact answer because the quantity of the uranium depends on the advancement of the design. If you have a very advanced design, you need very little amount of uranium-235. If you have a Manhattan sort of thing, very big thing, very bulky, 2,000 kilograms, then you can use lesser quantity. So the important thing is at what stage, what generation of nuclear weapon you want to design. That's the whole thing. It's not a question of just causing a bang. You want to have your nuclear weapon very reliable according to the predicted yield, and for that you need test and detailed simulation capability. So the actual size, weight of the device, and the amount of fissile material are part of the classified data of the weapon because they tell how much efficiency of the weapon, and it will also reflect details on the weapon design if you know the quantity of uranium-235. So that's the most sensitive. But we are using much less quantity of uranium-235 than people think. Because most of the people said that we have destroyed our reserves. We haven't. We have used very little uranium because our devices were extremely efficient.
Yeah, now there are certain comments which I can give you, and Dr. Samar already elaborated. The movement of these devices which we had, the development of these devices, we were given 7 days for taking these devices to Charlie. And we had to recheck all the devices, we had to pack them and then unpack them and to install internals, and all that was done in 4 or 5 days, out of which 4 days were taken by the army for shipping the things to there, and 1 day was given to us to take the things to the proper place and mount them. So some of the devices were just carried away in packings, opened and were used. And maybe you can imagine that this table could have 2 devices, you see, in size. So we moved them in helicopters. About the amount of uranium you have said, I mean, in literature you can find that 48 kilogram or U-235 will be supercritical if lying in a place. So when you are designing a device, it is a very much reduced quantity which will be used, as Dr. Masoor has said. So it was real hard work for us for the 15 days or so. As Dr. Samar has said, every one of us was relaxed, but none of us had slept from 11 to the 30th.
Dr. Tariq, please.
Dr. Tariq from the Center for Solid-State Physics. Nuclear emergence is obviously a scientific odyssey, and a scientific odyssey is an event which perhaps inspires future scientists to engage in science. One of the things that we have heard today is that the level of development of Pakistan in very many fields is quite backward, although as a nuclear power we are the 7th in the world. So my question is, what is the likely impact of Pakistan's emergence as a nuclear power on the development of science in Pakistan? So maybe some of the participants would like to comment on that.
Well, I would like to just say this, that it is a foregone conclusion that if you want to achieve any concrete results, you want to achieve something in a 3-dimensional context, a weapon system, a deliverable weapon system, or you want to have a missile, or you want to have something which is solid and it makes an impact on the defense of the homeland, 5 pushes are not going to do it. It's experimentalists, it's engineers and scientists, it's extremely good theoretical brains who are going to do this. We've got generations and generations of people who are happy with fireworks only, and this is not the thing which should be brought into the minds of the younger generation. Our young people must be inspired now that we have conducted these tests, and people must study science. Science has given strength to the country, it has given prestige to the scientists. For the first time, it has brought self-respect to the scientists.
Mr. Jawad, please.
My name is Jawad from UT. I wanted to ask that many Western scientists who were theoretically and practically on the nuclear weapons project, after when it was actually used at Hiroshima and Nagasaki, they felt guilty about it and weren't so sure about what they had done was correct. So if we actually use the weapon, if we don't have to use it on India, if we use it on a non-nuclear weapon state, my question is that what would your feelings be? I hope you have certainly thought about the moral aspect.
This is a hypothetical question, a very hypothetical question, and I think the answer lies in my speech when I said that we are not when you generate deterrence for your country, basically a good deterrence avoids the use of such weapons. The best use of this deterrence is not to use a weapon, and this is exactly why we went in for this deterrence.
Dr. Azim, please.
My name is Dr. Khalil Qurehi. My question is about CTBT. If Pakistan signed CTBT, what will be the fate of your program, program 15? What will be the future of these programs?
I think we have got press secretary and on CTBT, which is a purely now political issue. We have given our technical recommendations to the government. This is a purely political issue. It has become a political issue. And now I don't want to say anything on this at all. And it's a political issue. The government has to decide if they want enhanced deterrence beyond what we have already got. Then they have got to decide. They have got to make a decision whether they want an enhanced deterrence or not.
Dr. Shahid, please.
Muhammad Akhtar Shahid, Police Department, Government by Lahore. I would be interested to know the average neutron flux released as a result of the nuclear explosion which was carried out at the Sham. And my second question is that as we have heard from the press and also from the speech by Dr. Samar Mubarakmand, that the nuclear detonation was made by pressing a button. Now, as a teacher of nuclear physics, what I foresee that by pressing a button means making two masses, uranium masses, subcritical masses critical. But what I learned from Dr. Samar Mubarakmand's talk on nuclear explosion just now is that the technique which Pakistan Atomic Energy Commission used for conducting the explosion at Chavi was different. Would you like to comment on that?
Yes, about the neutron flux, you define flux as the number of neutrons per second. And I can tell, yes, the total flux in 4-5 we generate is 10 to the power 6 neutrons of that order. It's between 10 to the power 6 and 10 to the power 7. It means between 1 million and 10 million neutrons within a space of 4 nanoseconds. So it's the explosion when it takes place, the burst of neutrons just lasts for 4 to 5 nanoseconds, and the quantity of neutrons produced in that time span is between 10 to 6 and 10 to 7. That's up to you. As far as the detonation is concerned, it's an explosion, as I said to you, and it's a multi-point detonation. And you have to press some button somewhere. And when you press the button, we did it by telecommand from several kilometers. So the signal went through transmitters to dish antennas, and they were received at the near the tunnel by dish antennas, and then the signal goes into a computer which controls the device, and this computer then starts a sequence, a firing sequence. And the firing sequence has 5 steps. Initially, the device, to be safe, all the batteries are at 0 volts and all the switches are open, and the high voltage is 0. And when this sequence starts, then first of all it closes a safety switch, then it charges batteries. They are special batteries, they are charged within a few milliseconds, they are thermal batteries. Then you close another safety button, that's the second safety, and then you charge a high voltage supply, that's the firing supply several thousand volts. And then you close the third safety. So all the safety buttons are now closed and the high voltage is charged, and then you do the give it the firing signal. So the high voltage is put on the detonators and they fire. So this is sequence, 5-step sequence, lasts 31 seconds. So after we press the first button, everything is out of our control. Now it's in the hands of the computer at the site, which is now going through the whole sequence, and it does the firing. So this is how it is done.
Any more questions? Please ask him something.
After Qadri Rotary Club of Lahore, Shirki, what is the role of private industry in this program?
Unfortunately, the level of precision in the private industry when you got to make a nuclear weapon system, the mechanical engineering side, you have to machine parts and fabricate parts with a precision of a few microns. That's the accuracies we are talking about, because without this accuracy, you can't get the simultaneity of a few nanoseconds, as I was telling you. So the precision is not the way of life in our private industry. They do things more or less by just looking at things and guessing the dimensions of objects they make. So the private industry has a very small role to play in this, and this is why the program takes such a long time and such a large infrastructure for the Atomic Energy Commission to establish. We have to do everything ourselves. Mechanical engineering we have to do ourselves. Explosives we have to do. There is nothing in the private industry. Electronics we have to do ourselves. And everything it has to be done by us, because the level of expertise in the private sector is not so good.
So at no point in time you thought of maybe developing any sector of private industry?
You see, the problem is that when we go to private industry and we say, okay, manufacture this thing for us with this accuracy, they say, how many pieces you want? How many thousands of pieces you want? The problem with nuclear devices is that you're not talking of thousands, you're talking of less number than that, and therefore they are not interested unless it's a commercially viable proposition.
Please, no more questions. I'm really sorry, we are already short of time. A mention was made of the late Dr. Rafi Muhammad Chaudhry, both by Dr. Saadat Anwar Siddiqui and Dr. Samar Mubarakmand. At this juncture, I would like to request Dr. Samar Mubarakmand to present a bouquet to the daughter, herself a professor in physics. Please.
I have the honor of being her class fellow when I was in Government College Lahore, and I've known her for more than 35-40 years. And Dr. Rafi Chaudhry's son, most illustrious Dr. Anwar Chaudhry, is also here in the audience today, and you saw him when he asked some questions to me. Would you please get up and very world-renowned physicist and working according to his father's traditions, and we are very honored to have him here with us this evening.
Well, this was a very modest posthumous tribute to Dr. R.M. Chaudhry. I would now like to call upon the guest of honor of today's proceedings, Professor Dr. Khalil Qurehi, the Vice-Chancellor of the Punjab University, to share with us his conclusive views.
Bismillahirrahmanirrahim. As-salatu was-salamu ala khatamul anbiya wal mursaleen wa ala alihi wa sahbihi ajma'in. Dr. Samar Mubarakmand, Dr. Qurehi, Dr. Baig and Dr. Mansoor, and Dr. Saadat Anwar Siddiqui and the Honorable Office Bearers of the Khwarizmi Science Society and the Interact Club. I am really honored and humbled at the same time to have been invited to this evening's odyssey, as it has been described. And I was thinking, if it all this was written in the books in schools, how motivating it would be for the children. In our school curricula, the things they talk of is only the contributions of the West. What we have achieved, and I feel at my age that people like me start thinking what we have given to the younger generations, 50 years of Pakistan. But here is one example, and it has been rightly said, an island, I would say, an oasis in a desert, where dedication, devotion, teamwork, the kinds of things which we generally feel lacking in our society, they were there. And Dr. Samar Mubarakmand has very, candidly said he doesn't believe it to be a miracle. But I think given the conditions under which it has been done, it is nothing short of a miracle. That it has worked, and worked to such an extent against all odds, all kinds of difficulties that the international community put on us. And it has been mentioned the sanctions that were there right from 74, where our neighbors did something and we were penalized because they said we will